Hello guys, welcome to the channel. In this particular video, we will be looking at the problem Powerfull Integer. So let's see what it says. Here is the problem and it says that you are given a 2D integer array intervals whose length is n, where each interval is represented by this. It has a start value and end value, which means all the integers from start to end inclusively are also present. And we are also given an integer k. Now our task is to find the powerful integer. But what exactly is powerful integer? So powerful integer is that integer that occurs at least k times, and if multiple integers have at least k occurrences, in that case we have to return the maximum integer. Let me explain. So we are given intervals in the form of start and end. Let's take we are given three ranges, 1 to 3, then we have 7 to 8, and then we have uh, 2 to let's say 5. Now for this, when I say 1 to 3, then I will include the elements 1 2 3, and when I say 7 to 8, then I will include elements 7 and 8, and for this 2 to 5 I will include element 2 3 4 and 5, right? Now pay attention here. I have included 2 and 3 two times, so the frequency for this is going to be 2, frequency for this 3 is going to be 2, and the frequency of rest element is going to be 1, right? Now if we are given the value of k as 2, so for this the powerful integer will be that integer whose frequency is at least 2. And if we see here, then there are two elements whose frequency is at least 2. Out of these two elements, it says that if multiple integers have at least k occurrences, then return the maximum integer out of all those elements. So maximum here is going to be 3. Okay, now I hope you have understood this thing. So let's see the example which is given to us. For the example, we are given three ranges. First is 1 2 3. So I will write element 1 2 3. And for 4 to 6, we will write 4 5 6. Now we are given one more range, which is 3 to 4. So I will write 3 to 4 will be like this. Now if I write the occurrences of all the elements, so this is occurring one time, two time, then again one time and one time. This is the occurrences, right? And for these occurrences, if we look all the elements, then we will find that there are two elements who have frequency at least 2, and we need to look for the elements whose frequency is at least 2, right? So out of these two elements I will return the maximum one, so answer will be 4 for this. Now I hope you have understood the problem well, but there is one more thing to explain, which is if no integer occurs at least k times, then return -1. So this means that let's say we don't have this interval, so we will not be having this thing, and in that case the frequency of all the elements will be 1, right? And if the frequency is 1, so there is no any element who has frequency at least 2. In that case the output will be -1. Okay, so now let's move to the solution. Here I have written the same example which was given to us, and for this example, see here what we have done at this point. What we are doing is, whenever we have an interval, let's say we have interval 1 2 3, so if we have numbers like 1 2 3 4 5 6 and so on, right? So for this, from 1 to 3 I will increase the frequency of each element by 1. So the frequency will increase for 1 to 3 by 1 1 and 1, right? And now for this 4 to 6 I will increase the frequency from start to end by 1, so 1 1 1. Now what about this interval? For this interval again I will iterate from start to end, and I will increase the frequency, so it will be like plus 1 here. So now if I look at the frequency, so it will become 1 1 2 2 1 1. And for this we can simply iterate over all the elements, and we can look for frequency where frequency of I is greater than equal to k, right? This is how we check at least k occurrences, and if this is true, in that case answer will be that element, right? Answer will be I. And as we are iterating from smallest to largest, so I will have the largest element in the answer if I iterate over all the elements. How this will look like? This will look something like this. This is the pseudocode. You can see that for each interval I am again iterating in the range from start to end, right? from start to end, I am iterating over all the elements and I am increasing the frequency of that element. And when this task is done, then I will have the frequency array which we needed. You can see that here we have written one frequency array at this point, right? So we need this frequency array, and once we have this array, so we can just iterate over all the elements and check whether this condition is true. If this condition is true, in that case answer will be element, and at last I will have the maximum value which is the possible answer. So I will simply return answer. This is how we can solve this problem. But the problem with this approach is its time complexity. The time complexity of this loop is going to be O of n here, because it is iterating over all the intervals. And for this, again the time complexity is going to be O of max element, right? Because we can have the frequency the maximum element as max. So in that case, I will be iterating over all the elements from 0 to max. If I have interval like 0 and 10 raised to the power 9, this is the value of max, right? So in that case I will be iterating over all the elements, so I need O of max here. So the time complexity of this approach is going to be O of n cross m, which is not going to work for large inputs. You can see that the maximum value of m is even 10 raised to the power 9 here. So can we do something optimal? Of course we can do. Let's see what is the optimal approach. For the optimal approach, we need to observe one thing from the previous approach. Here what we are doing is, whenever we have an interval start to end, then we are iterating over all the elements and increasing the frequency by 1, right? So this is basically performing sum over a range. This is performing sum over a range, right? And the range is given start and end in this form. So let's say we are given range like from 1 to 3. Okay, we are given range from, let's say, 2 to 5, and I have this array. I have the array as initially the array. If I initialize the frequency array, so I'll initialize all the value with 0, 0, 0, 0, 0, 0, 0, and I need to increase the frequency by 1 in that case. So I'll do something like this here. So I will have elements. Let's say I have 6 elements, right? So I need to increase the frequency of element from 2 to 5 to, okay, so if I take the index, so I'll write 2 to 5, 0, 1, 2, 3, 4, 5. I'll increase the value in this range by 1, right? How we can do this? The first way is iterate over all the elements from start to end. So I will do something like for which we were doing here, like iterating from start to j and then increasing the frequency. The second thing is we can just put this value, we can just put 1 at this index. So if I put 1 at this index, so this value will now become 1, this value will now going to be 1, right? And now we can perform the prefix sum, and prefix sum, what it does is it keeps increasing the value ahead of this value, right? So if I perform the prefix sum, then I will have the value like 0, 0, 1, and now as I have the sum as 1, so it will keep putting 1 everywhere, right? But hold on, we don't wanted 1 after this, right? We just wanted 1 in this range, 1, 1, 1, and 1, like this. But we are getting 1 in this range as well, but we don't wanted 1 in this range. In order to avoid this thing, we need to do something which is going to end the effect of increasing this 1 after, just after the end interval, right? Just after the end interval means that if I have start and end, so just after the end means n plus 1, n plus 1. So if I put minus 1 here, then this 1 is going to be minus 1, right? 1 minus 1 is going to be 0, and then I will have 0 here. I hope this makes sense to you. So what I'll do is I'll make frequency of n plus 1 equal to minus 1. And if I do so, in that case I will be having elements like this, and my task is done, right? Okay, so is it going to work for multiple queries? Is it, first of all, let's see, is it going to work for any other value other than 1? Let's say I have the general value which is k, right? So in that case I can simply make k here, and I will put minus k here, and then if I perform prefix sum, so I will be having 0, 0, and then k, again k for this, k for this, k for this, and 0 for this, right? So it is a general thing which is going to work for all the values, whether I have to add 1 or 2 or 3 or k, right? But in our problem, the problem which is given to us, we need to increase the frequency by 1. So that's why I'm increasing by 1 here, right? Fine. Till now we have figured out one thing, that if you are given interval which is start to end, in that case I can do one thing. I can make my frequency of start equal to 1, and I can make my frequency of end equal to okay, end plus 1. Just after the end I can do, let me erase this. This is something important. Just after the end means n plus 1, and it will be minus 1, right? And if I perform prefix sum after this, in that case I will be having my answer. So is it going to work for multiple intervals as well? Let's say I have multiple intervals. I have intervals like this. If you see here, then we have 3 intervals, right? So is it going to work for 3 intervals? The intervals are, the first one is 1 to 3, the second one is 2 to 6, and the third one is, okay, so second is not 2 to 6, it is 4 to 6, and the third is 3 to 4, right? So let's do it for multiple intervals. We have the array, and as the maximum element is 6, so I will write 0 0 0 0 0 0. I have 6 elements here, right? Fine. So what I'll do is, I will first make this this is the start, like this is start and this is end for all the elements. So I'll make start increase by 1, so it will become 1. And what about the end? End plus 1, which is the fourth. 1 2 3, and just after 3 is 4, right? So I will decrease this value by 1. I hope this makes sense to you, because I have already explained it. What about this 4 6? For this 4 6, I will increase the value at 4 by 1, so it is basically 4. So I'll increase by value this value by 1, so I will have 1 here. And what about this 6? I will decrease the value just after 6 by 1, but there is no value, so there is no need to decrease, right? Because we decrease because we want to end the effect just after that element. But if there is no element after this 6, then there is no sense of decreasing at this index, right? Fine. What about this 3 and 4? For this 3 and 4, first of all, I will increase the frequency at 3 by 1, and then I will increase the frequency at I will decrease the frequency just after the 4. So if I have 4 here, so I will decrease the frequency after 5, right? It will be minus 1. Fine. So let me just recap this what we have done. So first of all, 3 and 4. So 3 is 1, and 1 2 3 4 is going to be minus 1, and after this we have this thing, right? So if we increase the frequency of 4 by 1, in that case I will be having 0. Fine. And what about this? What about this 6? This 6, here we need to do minus 1, but there is no sense of doing this. And for this 3 and 4, first of all I will increase the 3 by 1, and I will decrease this value 4 by minus 1, right? Fine. So now if I perform the prefix sum, I will be having values like 1 for this, 1 for this. For this I already have 1 and I have this one, so it will become 2. And for this again it will become 2, and for this it will become 1, and for this it will become 1. Fine. So this is the frequency array that we are going to have by performing the prefix sum. And you can notice one thing, that the frequency array seem like this, right? This means that the approach is also going to work for multiple intervals. And now one more thing that I need to discuss is, here if you see, then we are not actually just replacing the value. Instead we are increasing this value, right? We are increasing this value. You can see here that when we have minus 1, then we are doing minus 1 plus 1, and that's why I have 0 here. So we are actually increasing this value. Now we have got our approach. What we can do is, we can iterate over all the elements. So iterating over all elements means for each interval, if I iterate over all the intervals, then I'm going to have start and end here, right? Start and end here. And once I have this start and end, so I can do frequency of start plus equals to 1, and frequency of end plus 1 will be minus equals to 1, right? Okay, now this is the thing that we need to do, and once we are done with this thing, then we can simply perform the prefix sum. So after this, just after this, we can perform the prefix sum. So here I can do prefix sum, and once I am done with prefix sum, after this I can just do the same thing that I was doing here. If you notice here, then I can, once I have the frequency array by performing that thing, then I can do this thing, right? Okay, now I hope you have understood this approach. So let me show you the code. So you can see that I have the Java code on the left hand side and C++ code on the right hand side. And for the Java code, first of all, I'm finding the maximum element that I have. And for this maximum element, I need to make this array of max, right? You can see here. You can see here that I'm making an array of maximum. Why? Because the element, what is the maximum size of this frequency array? For this, I need to look for the maximum element that I can have, because I need to increase the frequency at that place as well, right? Fine. So this is what I'm doing, and after this, once I have made my frequency array, I can just do this particular thing which I have already explained you. Fine. And at this point, I'm performing the prefix sum, and along with this, I'm also checking this particular frequency. So I'm doing two tasks in just one loop, right? Okay, now I hope you have understood this thing. So the C++ code is very similar to the Java code, and the Python code is again very similar to the C++ and Java code. You can see here. Now this is all about this video. If you guys like the explanation, then you can hit the like button and subscribe the channel. Thank you.